The availability of 3D printing pen allows direct drawing of 3D wire sculptures for novice users. But to draw a high-quality wire object in 3D is much more difficult than conventional drawing in 2D. The extra degree of freedom poses new challenges and often leads to highly distorted and even incomplete wire sculptures. For example, the stroke order is very important for 3D drawing. Every 3D stroke needs to have physical support and cannot be drawn in the air. This is different from 2D drawing where the stroke order can be very flexible. Also, wrong ordering between strokes is very likely to cause occurrence between existing strokes and the 3D printing pen, leading to unreachable strokes and incomplete wire object. Besides, it is hard to control the trajectory of strokes in 3D and keep the spatial relationship between strokes. As a result, the user may get confused in the drawing process and make mistakes or spend a lot of time to figure out the right drawing context. To make 3D drawing easier, we propose a mixed reality-based system called WireDraw to immersively guide the 3D drawing process for easy wire sculpturing. By using our system, the user can easily sketch high-quality wire objects. To guide the 3D drawing process, our system generates an optimized stroke sequence and the corresponding viewing direction for drawing each stroke. The optimization is based on a set of quantitative drawing principles. First, we have to make sure that the wire object is drawable, which means the strokes should be ordered in a way that every stroke must have physical support. We call this principle dependency. We also propose several principles to make the drawing process easier. For example, low complexity ensures a small number of strokes in the wire object. Reachability takes into account the occlusion when drawing each stroke, and so on. We further investigate how to quantitatively measure the proposed 3D drawing principles. For the details, please refer to our paper. Based on the quantitative measurements, we propose a simulated annealing-based optimization, which optimizes the stroke sequence and the viewing directions of individual strokes. This example shows the optimization procedure where the stroke formation and sequence are optimized. The convergence of the optimization is shown at the upper right. The stroke ordering is color-coded from blue to red. We also assign an optimized viewing direction when drawing each stroke to avoid depth ambiguity. The wire model is rotated according to the viewing direction. The optimized stroke sequence is further integrated into a mixed reality-based system to immersively guide the user for easy 3D drawing. Our mixed reality system of an Oculus Rift head-mounted display and two Logitech webcams. The two webcams are attached to the Oculus Rift using a 3D printed adapter. The distance between two cameras can also be adjusted on the adapter. Here is an example of using our system for 3D drawing. We illustrate a circular marker on the pen to give user feedback on the spatial relation between pen nib and the current stroke. The strokes will be shown one by one according to the optimized sequence. Each stroke trajectory is animated from the starting point to the end point to simulate the real drawing process. The entire reference model is rendered assigned to give user the overall drawing context. All the virtual guidances provide strong spatial and structural cues for easy 3D drawing. Based on the pen nib tracking, our system also supports on-the-fly editing for creative design. If any stroke is unsatisfactory, the user could use a pen to pick that stroke as highlighted in red and then delete that stroke. Besides, users can also draw a new stroke to replace the previous one. Here, we show a number of user-created wire objects by using our system. Please refer to our paper for the user study and a full comparison with wire objects created with other drawing guidance.